In this video, we will see why do we take omega t minus beta z as constant. Okay, in the derivation of the phase velocity. Generally, because omega t minus beta z is constant, we can write omega dt minus beta dz by differentiation. It is equal to constant differentiation is 0. Then we can write dz by dt is equal to omega by beta, because distance by time, so it is a phase velocity. So phase velocity Vp is equal to omega by beta. This is the general equation can be used for the electromagnetic wave in any media. Lateral beta is equal to omega root of mu epsilon can be substituted. Then we can take Vp is equal to 1 by root mu epsilon as the velocity. This is okay. But what is the reason for taking omega t minus beta z is equal to constant? About this one we will discuss in this particular video. Actually, this omega t minus beta z is the phase of electromagnetic wave. You can see the electromagnetic wave, electric field or the magnetic field having the expression. In the expression, you can see e power j times omega t minus beta z or cos of omega t minus beta z or sine of omega t minus beta z. And you can take plus beta z also when the wave is traveling in the negative z direction. Now minus beta z means wave is traveling in the positive z direction. And in place of a z, you can take x and y also based on the direction of propagation. Whatever it may be, for the explanation purpose, I am taking here cos of omega t minus beta z. I am not taking the complete expression for the e bar or the h bar. My focus is on this particular phase only. Okay, so you may have e power minus alpha z. Okay, and if it is the electric field and that can be oriented in the x direction, like that you can able to take. So whatever it may be, as I said, my focus is on the phase only, that is omega t minus beta z. Like this I am taking. So since the phase is the function of time and space, here t is there, so phase is the function of time. Here z is there, so the phase is the function of distance also. This is the main point. So phase is function of both time and space. Time and space. Okay. So in order to understand this particular thing, we will fix a time value and we will draw this with respect to z. And you can assume in this analysis alpha is equal to 0 for simplicity. Then we will fix a time at t by 4, that means quarter of the time period. Then again we have to draw. Then we will fix the time at t by 2. Then we will draw the graph with respect to beta z. Then what will happen, we'll see. We'll take one point, how that particular point is moving in the positive z direction, that one we'll analyze. Okay. So whenever t is equal to 0, it will become cos of minus beta z. That means cos beta z. When you take t is equal to t by 4, it is a quarter of the time period. That means t by 4, it is leading to quarter of 2 pi. Quarter of time period will be leading to quarter of the 2 pi, that is pi by 2. So pi by 2 minus beta z, this is equal to sine beta z. Then at t is equal to t by 2, what is omega t? It is half of the time period. That means half of the 2 pi is pi. Pi minus beta z, so it will become minus sine beta z, minus cos beta z. So we are going to draw this cos beta z, this sine beta z, and this minus cos beta z, and we will analyze what is the position of the one particular point on the graph. So I am taking like this. I will take beta z here on x-axis. Now we have to draw this cos beta z with respect to beta z, Sin beta z with respect to beta z and minus cos beta z with respect to beta z. Okay, and just I will represent here pi by 2, pi, 3 pi by 2, 2 pi, and it is 0. Okay, and this is for t is equal to 0, it is for t is equal to t by 4, and then last one is for t is equal to t by 2. If you see the first one, we have to draw cos beta z, and cos is taking a maximum value at beta z is equal to 0, and getting 0, I will change the color, and getting 0 when it is pi by 2, and getting minus 1 when it is pi. Okay, then again 0 at 3 pi by 2 and getting the plus 1 at t at 2 pi. So accordingly, you can able to draw the plot for cosine function like this. Now just for analysis purpose, I will take the point is P. This point I am taking P. How it is moving as t is progressing, we have to see. Okay. So now at t is equal to t by 4, that means after completion of one quarter cycle, how the wave will be moving in the positive z direction. That is what we will see. So at t is equal to t by 4, we got here sine of beta z. Okay. So it is a sine function at beta z is equal to 0, sine is 0. At pi by 2, it is getting the value is 1. At pi, it is 0. At 3 pi by 2, it is minus 1. At 2 pi, again, it is 0. Okay. So if you draw, you get like this. Okay. So as time is progressed by quarter of the total time period, the point P is now available here. Okay. Then at t is equal to t by 2, we have to draw minus cos of beta z. Minus cos of beta z. So it is just negative of the first graph. So if I draw this one, I will get like this. Okay. Now where is the point P? Point P is available here. So what we need to understand here means always the point P is with the same phase. Okay. The point P is with constant or same phase. That is what we can able to understand. That is why omega t minus beta z is equal to constant. Omega t can be changing as per the t values. Now if you take t is equal to 0, omega t is 0, and beta z, if you observe it for the point P, if you observe a t is equal to 0, what is omega t minus beta z? You calculate that one. Omega t is 0, minus beta z is also 0. So it is 0. Okay, total phase is 0. Now for the point P, a t is equal to t by 4 we'll see. A t is equal to t by 4. Again, I'm calculating omega t minus beta z. For the point P only you see. Okay, so omega t minus beta z I am calculating. A t is equal to t by 4. Omega t will become pi by 2 minus. Now you focus on beta z. A t is equal to t by 4 means you have to see this graph. And P is available for what values of beta z? Beta z here it is pi by 2. So I'm writing here pi by 2. So omega t minus beta z will become again 0. Now you see for the point P, whether it is at t is equal to 0 or at t is equal to t by 4, total phase became 0. Now you can check for the third case also. For the point P, at t is equal to t by 2, omega t minus beta z I am calculating. So omega t is at pi minus, because it is half of the time period, omega t will become pi, and beta z. See from the graph, third graph, for the point P, this is available at beta z is equal to pi. That means again omega t minus beta z is became 0. So what did we understand here? If you take one point on the wave, that point is always with the same phase as time is progressing. As time is progressing, the point will be with the same phase, that is omega t minus beta z. So I can take now, you can see here 0, 0, 0 we got, so that omega t minus beta z is equal to constant. Okay, thank you.